For our second example, we will be using the built-in empty cars dataset in R. This dataset contains measurements on 11 different attributes for 32 different cars. In this example, we will explore the relationship between a set of variables and miles per gallon. However, we will only use three independent variables, which are the displacement, gross horsepower, and transmission type. First, we fit the regression model using OLS and we get this equation. Next, we fit the regression model using the Quantile regression through the following R codes. Another way lang to ng pag-compute for Quantile regression model, pero same lang naman yung magiging output kung yung sundin nating R codes ay yung binigay sa first example kanina. Ito naman yung susundin nating equation na halos kamukha lang din nung sa OLS, tapos hanggang beta 3 hat na siya since tatlo na yung gagamitin nating independent variables. Tapos, ito naman yung corresponding fitted regression models per quantile. Since may 32 observations lang yung empty cars dataset, we still have a small n, so gaya sa first example, yung summary function uses SE equals rank, and this returns yung lower bounds and upper bounds or yung confidence interval ng ating coefficients. In this slide, we can see in the table the summary of the OLS regression coefficients and yung quantile regression coefficients at different quantiles. Gaya sa first example, yung asterisk or star beside the coefficients represent yung significant difference nila from 0 at 5% level of significance. While yung plus sign naman represents the significant difference of the quantile regression coefficients from the OLS coefficients. Unlike the first example, makikita natin dito na may isang quantile regression coefficient which is yung gross horsepower or yung HP sa 0.75th quantile na significantly different from the OLS coefficient. So sa example na to, masasabi natin na may sense naman na mag-compute tayo for quantile regression. Again, looking at the table, makikita natin na tumataas yung quantile regression coefficients ng displacement and transmission type variables as the quantile increases, while bumababa naman yung quantile regression coefficients ng gross horsepower as the quantile increases. Thus, for our interpretation, by looking at the trend of the relationship between the dependent variable and the independent variables across the quantiles, we see that the effect of the displacement and type of transmission increases as the quantile increases, while the effect of the gross horsepower decreases as the quantile increases. Lastly, we did a formal test of significant difference using the Wild test, and makikita natin na yung p-value na nakuha ay 0.005367, which is lower than our alpha. So for our interpretation, looking at the output, we can see that we got a significant result, meaning the models at the three quantiles are significantly different from each other. This being said, we have sufficient evidence to conclude that the joint effect of the independent variables on the dependent variable differ in the models of at least one pair of quantiles. This also tells us that the model is significantly different across different quantiles, therefore incentivizing the use of quantile regression.